Hello everyone, my name is Signolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it.
This is our first lesson on functions, and the first kind of function that we will be looking at is the straight line or the linear function. Okay, so that's the first kind of function that we will be looking at. Okay, so focus of the video is functions, and we will start off with the linear function. Okay, the linear function, or the straight, you can call it the straight line. It's just a straight line. Okay, so the straight line. Okay, now before we actually get to looking at this video or at this function, this specific function, firstly let us establish what makes a function a function. Okay, what is a function? Okay, so a function is as follows. A function is simply a description. So you've got a description here. You've got a description. But a description of what? Well, you've got certain values here and you've got certain outputs here. Okay, you can call this I for input and you've got O for output. Now, for every input value, you've got different input values. Okay, for every, these are not zeros, these are just these are just circles representing input values. For every input values, you've got output values. Okay, for every input value, you've got an output value or output values. Okay, now the description in the middle here, is the equation. This is an equation. This equation tells you that if you take this input value, you are going to get this output value out. Okay, if you take a specific input value, you're going to get a specific output value. So it's basically just a relation. It's a description. It relates your input values to your output values. Now, your input values will usually be in the form of x, and your output values will usually be in the form of y. X represents your input values, and y represents your output values. Now, you can have more than one input value. In other words, you can have more than one x for the same output value. Okay, you can have more than one x for the same output value, and the inverse is also true. You can have more than one y for the same x value, or for more than one x value. Okay, so there are terms for this stuff: many to one to many to many, and stuff like that. I'm not going to get into it into this video. I think it's only going to be more confusing. But the point of my explaining this thing is I want to explain exactly what a function is. Now, a function is the description or the equation or the relation between certain input values to certain output values, but there is a condition that it must satisfy. There's a condition that this equation must satisfy for us to qualify this or to call this a function. Now, a function is an equation or a relation that has one output value, one unique output value for one or more x values. Okay, so for one or more x values, you can have only one unique output value. Now, I know that probably doesn't make a lot of sense right now, so let's give you an example. Okay, so say you have a Cartesian plane, right? You've got a Cartesian plane, and we know that this is the x-axis. So all the values here are your x values or your input values. I call them input values. And all the values on the y axis are your output values, or the values that you get out, the values that you get from a specific x values. Now, let's say we're looking at a straight line, right? Let me just use a different color for that. Say you're looking at a straight line that goes like that. Okay, it's a straight line that goes like that. We're still gonna cover the equation of a straight line and all the related concepts regarding a straight line. So if you look at the straight line here, the straight line is made up of a combination of x values and y values. Okay, so you've got for this specific x value at that point there, if you draw a straight line towards the graph, okay, perpendicular to your x-axis, if you draw a straight line perpendicular to your x-axis, it hits the graph there. And if you draw another straight line perpendicular to your y-axis, it hits it there. So this value that you see here is on your y-axis, so that's your output value. Your input value is your x value there. Now, for this x value, there is only one output value of y that relates or that corresponds to that x value. Okay, there's no other point. It's only at that point where you've got your y value for the specific value for x. And this is the case for every other value of x. Okay, so if you look at, say, that x value, for instance, there, right? This is your input value. And if you draw a straight line towards your graph perpendicular to your axis, your line will be there. And then if you try to find the corresponding y value, the corresponding y value will be there. This is just, it's the only value, it's a unique y value of your x value. And this is why we call this a function, because every input value of x only corresponds to one output value of y, just one. As soon as it becomes more than one, then it's not a function anymore. So a function is a relation or a description of a relationship between an x value or x values and one y value. Okay, let's give you another example. Okay, so we're gonna cover the different kinds of functions in other videos, and in this video we'll cover the straight line, but now I'm still explaining what a function is. So now let's say we still have our y-axis and our x-axis, the Cartesian plane like that, and then these are your x values, so that's your x-axis and this is your y-axis. Okay, now let's say you have a graph that looks like this. Okay, this is a parabola. We're going to cover it in a separate video, but let's say you have a graph that looks like this. Now if you draw, or if you identify your x values, your x values are here, right, all along the x-axis. This is where your x values are. Now, is this thing a function or not? Is this graph that I drew in a function or not? Well, you can test. How do you test? Well, you want to see if you've got an x value or more than one x value that corresponds to more than one y value or just one y value. If the x values correspond to one y value, then this is a function. If the x values or x value correspond to just one y value, this is a function. If not, then it's not a function. Okay, so I can choose any x value. Let's say I choose an x value here at that point there, and I draw a straight line perpendicular to the axis towards the graph. What do I get? I get that perpendicular, so that's perpendicular there, right? I get that line hitting the graph at that point, right? At that point there. Now remember, this graph continues on forever. This is what these arrows mean, right? And the graph continues on together. I mean forever, not together, right? So you've got that x value there at the bottom corresponding to which y value? This y value here. Is it more than one y value? No, it's not more than one y value. It's just one y value. Okay, so let me try it again somewhere else. Let me use this x value here. Doesn't matter which x value you choose. If I choose this x value and I draw a perpendicular line, lightning, and I draw a perpendicular line towards the graph, then it hits the graph at that point. And if I move towards the other axis, then the y value that it corresponds to is that value there. So this is still one y value. Okay, this is one y value and it's separate from that one. It's not the same as that one. Okay, now what would the case be if we were dealing with a graph that's not a function? Well, let's have a look at that. Okay, so if we were dealing with a graph that's not a function, we would have the following. We've got your Cartesian plane. There's your Cartesian plane there. And then you draw in your graph. Let's say draw in my graph that looks like that. There's my graph that looks like that there. Okay, now is this a function or not? How do we test? Well, remember, these are all your x values, right? Your x values are on your x-axis, so it doesn't matter where, even between these lines, everywhere. As long as it hits your x-axis, it's an x value. Okay, so now, is this a function or not? Well, to test if this is a function or not, well, firstly, you've got to check if you've got an x value or more than one x value corresponding to one y value or more than one y value. If the x value corresponds to more than one y value, then your thing is not a function. Okay, to more than, if the x value corresponds to more than one y value, then this is not a function. Let's see. Let's pick a point. Let's pick an x value there. We're picking an x value there. Okay, remember what I do? I pick an x value on the x-axis, then I draw a straight line perpendicular to the x-axis towards my graph. Towards my graph there. Okay, so it's towards my graph. It hits my graph there, and then I go to the y-axis. So there's my y value there. There's my y value there. But then nothing tells me if I should draw my line up or down, right? I could draw it up or down. It could be either way, up or down. Now here, I drew my line towards the graph in the positive vertical direction, but I could have done the same thing down here, right? I could have chosen my x value at that very same point, the very same x value, and then I move towards the graph, right? I move towards the graph, and then it hits the graph there at that point. Then I move towards the y-axis there. Okay, so now I've got another y value that corresponds to the same x value. It corresponds to the same x value. So this is not a function. Why? Because we've got one x value corresponding to two y values. A function only has one output, one, not two, one output for the same x value or for different x values. Okay, or for different x values. What do I mean when I say for different x values? Well, let me go up there and show you something. I should have mentioned this actually earlier on. Now, if you look at this graph, this parabola here, right? This parabola here, the x value at that point, corresponds to this y value. But the x value at this point as well, if I draw a straight line towards, not at this point, sorry, just let me remove that. Say at that point there. At that point somewhere there. So the x value at that point somewhere there, if I draw in a straight line towards the graph, I hit the graph, say I hit the graph somewhere there, right? Straight line, I hit the graph somewhere towards there, and it intersects with my graph there, and I move towards the y-axis. It hits the same y value there. It is the same, it shares the same y value. So these two values of x have the same y value. They have the same y value, but that's fine. This is still a function. Why? Because we only have one y value. The y value is the one that's got to be unique. The x values don't have to be unique for the same y value, but the y value has to be unique for different x values or for the same x value. Okay, so this is why this is a function. This is what I mean when I say that this the equation or a function is a relation or a description of one x value or more than one x values, and it relates it to it's a description of the relationship between one or more x values to one y value. Okay, so that's what a function is, and this is why this is not a function. Okay, so that's what a function is. So this is not a function. I'm going to repeat myself. This is not a function. This is not a function because, okay, so this is a function. This is a function because you've got the same x value here corresponding to more than one y value. Okay, so this is why this is not a function. It's not a function because it has an x value has more than one y value. Let's do another diagrammatic example so that I can hammer the point home. So you've got, let's say this is your Cartesian plane, and you've got a graph that looks like that. Okay, you've got a graph that looks like that. Now, is this a function or is it not a function? Well, the first thing you do is you pick any random x value. Any random x value, let's say I pick this x value there, right? I pick that x value there. Then from that x value, you draw a straight line vertically, perpendicular from your x-axis, goes up like that. It hits your graph there. Now, where it hits your graph, it corresponds to a value of y there. From the same x value, you can draw your line vertically downwards so that it hits your graph there and it corresponds to your y value there. But then again, from this same x value, you can draw your graph up and it hits your graph there and it hits your y value there. So you can already tell that we've got this y value, we've got this y value, and we've got that y value. Now these are three y values. It's not unique because all these three y values share the same x value here. They are from the same straight line, right? They share the same x value, so this is not a function. It's not a function, right? And this whole process that I just followed here, they call it the vertical line test. Okay, they call it the vertical line test because you draw a vertical line to see if that vertical line cuts your graph at more than one place. If a vertical line that you draw cuts your line at more than one place, then this is not a function. Okay, so this is actually a simpler explanation. Let me use the previous example that I used before. So if I draw my Cartesian plane, Cartesian plane, Cartesian plane, and I draw in my graph like that, graph that looks like that, if you take a vertical line and you draw it through this graph, right? It's just a random vertical line. It cuts your graph at more than one location. So it's not a function. Because if it cuts your graph at more than one location, then it means it has more than one y value. Okay, so if we go back to our initial examples where we actually do have functions, what you'll notice that if I draw a vertical line here, it only cuts the graph there, right? If I draw a vertical line there, it only cuts the graph there. If I draw a vertical line there, it only cuts the graph there. So this is a function. Okay, it's a function because the vertical line cuts it at that point. Same thing for the straight line here. If I draw a vertical line here, it only cuts the graph here. If I draw it here, it only cuts the graph there. If I draw it here, it only cuts the graph there, right? So for every vertical line with a specific x value, it cuts the graph at only one y value. Okay, not more than one y value or more than one point. Okay, so this is what a function is. Okay, so I think it's a good time to stop this video here. This video will just be dedicated to learning what a function is and what a function is not. And in the following videos, the videos that follow after this one, then I will start looking at the actual types of functions, and we can start doing some examples. Okay, so that is what a function is, and that is what we will be looking at for the next couple of videos. Till next time. Lesson number one.